Lesson 13, we are constructing triangles today. That's why you have protractors and rulers on your desks. We are going to make use of the triangle inequality and the triangle sum theorem that we learned last week to make sure the triangles can even be created before we construct them. And you're learning this because if you are interested in architecture or engineering, you would have to know how to do this. First thing on your notes, I would like you to give this a shot. Go ahead and try drawing a triangle where one of the lengths is 5 centimeters, the others could be whatever you want, and one of the angles is 120 degrees, the others can be whatever you want. Okay, after you draw that, we're going to compare with our shoulder partner to see if they drew exactly the same thing you did, and then answer some questions. So go ahead and draw a triangle where one side is 5 and one angle is 120. Please look at your neighbor's paper and see if they drew exactly the same thing as yours. And exactly the same means you can put your paper on top of theirs and like rotate it and it would match. It has to exactly match. If it doesn't, then that means you drew different triangles. You and your partner drew different triangles. It didn't match because there's lots of different ways to draw this. So let me show you what I did. Here's my ruler. I measured out 5 centimeters. And then I put my protractor on one of the ends to draw my 120 degree angle. So if this is my 0 on this side, 120 would be opening this way. And then I just had to close it to make it a triangle. So this was my triangle. Most of you probably drew it this way because we all have the same size protractor. But remember that angles have rays that go on forever, right? If I drew it really long and I didn't just stop at the end of the protractor and you just had to close it to make it a triangle, wouldn't it be a bigger triangle? What if I made it shorter? I don't have to go all the way to the end of the protractor. I just have to make sure it's 120 degrees. So I could have stopped here and made it like this and have a smaller triangle. Do you agree that those are different triangles? They don't match exactly on top of each other, right? This one is smaller and flatter, but it still has the 5, and it still has this angle matching. They're both 120. So what I would like you to write on your notes is that the triangles are different. So you can draw a big one like this or a small one like this. Go ahead and sketch that on your paper just so you have an example, and then write many triangles are possible. Go ahead and do number 2 and give this one a shot. I would like you to draw a triangle where one of the angles is 90 degrees and the other angle is 60 degrees. The third one could be anything, whatever happens on your paper. I don't tell you anything about the lengths, so it could be whatever you choose. But draw a triangle where one is 90 degrees inside and one is 60 degrees inside. One triangle. Here is my .90 degrees, and here is my 60 degrees. So here's my, I just moved it. 90, there. Here's my 90 degrees, and here's my 60 degrees. Is the blue and the red triangle exactly the same size and shape and everything?
Yeah, the shape.
Everything's the same? No, the blue one is clearly smaller, right? But they both follow the rules. They have a 90 degree angle and a 60 degree angle. And I can make this whatever size I wanted. I can make this one bigger, I can make this one smaller. So there's a lot of different triangles you could have drawn, right? So that's proof that this is many triangles possible. So go ahead and write this on your notes. Many triangles are possible because this is what's called similar figures. If they're exactly the same shape but different sizes, it's a similar figure. Let's try one more. Number 3. Give this one a shot. Draw a triangle where one side length is 4 and the other side length is 6. And a third one just connected to make it a triangle. Most of you did not draw exactly the same triangle because you could have drawn it where this is my 4 centimeters and then I open it as an obtuse angle. Here's my 6 centimeters and I just connect it to make it a triangle. Or let's see, here's my 4 and I wanted to make it an acute triangle so I don't open it as wide. It goes more up instead of open. And then I connect it to make it a triangle. Do you agree that they're different? This one's obtuse, this one's acute. Different triangles. So I would like you on your notes to write that many triangles are possible. Now think about this. Those 3 problems we just did, there is a pattern that happened. What do you notice about all the information that I gave you? How many pieces of information did I give you? 2. For every one of those 3 problems, I only gave you 2 pieces of information. And for all 3 of them, your answer was many triangles are possible, right? That means that 2 pieces of information is not enough for you to draw exactly the one I wanted you to. 2 pieces of information is not enough, fill in the blanks on your notes, to create a unique triangle. Unique means there's only one of its kind. Just like there's only one of you in the world. If you lie sideways on your bed, you're still the same person. If you're upside down on the monkey bars, you're still the same person. If that triangle is sideways or upside down, it's still the same triangle. Unique means there's only one of its kind, even if it's sideways. But if I give you 2 pieces of information, you all drew different triangles. Right? All right, back to your notes. Number 4, please draw this. This time I'm giving you 3 sides, 3 pieces of information. A 6 centimeter side, another 6 centimeter side, and a 4 centimeter side. Make that into a triangle. Draw lightly because you will probably have to erase. They're not straws that you can move around. They're pencil lines that you need to make match. And then when we compare with our partners, I want you to make a conjecture about the number of triangles you can draw. Is it 1 triangle or many triangles? And a conjecture is making a conclusion based on a pattern. So before we even start drawing, let's use our knowledge from last week. Will this even make a triangle? Are we wasting our time here? Triangle inequality means that small plus medium has to be bigger than the large. 4 plus 6 is 10. Is 10 bigger than 6? 10 is bigger than 6. That means that we can at least make 1 triangle. But how many triangles can we make? 1 or more? Look at your partner's paper. Did they draw exactly the same thing you did? Even if it's sideways, it's still the same triangle. Okay, I asked you to draw 6, 6, 4. So it looks like this, right? 6, 6, 4. Yours might be standing straight up. It might be lying down the other way, but it still looks like 6, 6, 4, right? And you all drew a triangle that looks very, very similar. So I would like you to, on the 3 lines on your notes, please write on the first line that only 1 triangle is possible. You all drew the same thing. And this is because, on the second line, write that this is defined as a unique triangle. I gave you 3 specific side lengths, meaning you would draw exactly that triangle, that unique triangle. And on the third line, please write SSS. That stands for side, side, side. I gave you 3 sides. That makes a unique triangle. A side, side, side unique triangle. So on your homework, if I gave you 3 lengths and I say, does this make a triangle? How many triangles? What kind of triangle? Or why? You would say, yes, it makes a triangle because triangle inequality says that this would make a triangle. And it's only 1 triangle because this is a side, 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 SSS, unique triangle. If I asked you what kind of triangle, you can say isosceles because 6 and 6 are the same. Any questions about this? Let's go on to number 5. This time I'm still giving you 3 pieces of information, but this time I'm giving you 3 angles. Draw that triangle on your paper and let's see if you and your partner draw exactly the same thing. We want to make a conjecture on the number of triangles that are possible. Is it going to be 1 triangle only, like you and your partner draw the same thing, Or are there many different triangles you could have drawn? Again, before we even start wasting our time, let's make sure it even makes a triangle using the triangle sum theorem. Which means all three angles have to add up to how many degrees? 180. Good. All triangles make 180. Does 80 plus 40 plus 60 equal 180? Yes, so we at least know we're not wasting our time, that this is not an impossible triangle. It can make at least one, but can it make more? Look over at your neighbor's paper. Did they draw exactly the same thing? Same size? Same shape? Let me show you what I did. I started out with a line, because I need to draw an angle. I didn't specify how long to make the length, so this line could be whatever you wanted. Let's make that into an 80-degree angle. So here's my protractor, there's 80, I drew my line. Then, instead of turning the protractor sideways, I turned my paper sideways. So now this is the bottom. And I made my 40-degree angle, which is here, going through 40. And it happened to match up to my line. So I just need to make sure that this one is 60, because it had to be a 60. So I'm going to turn it back around and measure it. Does it go through the 60? Yeah. Yes. So here's my triangle. But remember, angles go on as rays forever. So I could have made this a lot longer, right? I could have done it like this as my first line, really short. Made my 80, made my 40, made my 60. I still follow all the rules. It's just smaller, right? How many of you drew a triangle that was smaller than your partner's? How many drew one that was bigger than your partner's? Okay, so you follow the rules, but you got different triangles because you can make many triangles. Please write this on the first line. They are called similar triangles, similar figures. One is bigger than the other, but they are all 80, 40, 60. Could have been small, could have been big. So today we learned that if I give you two pieces of information, is that enough to draw a unique triangle? Yes or no? No, 2 pieces of information is not enough. 3 pieces of information is sometimes enough. Right? This was 3 pieces, but did you draw the same triangle? No, so 3 angles is not enough, but which one was? Which one gave us a special unique triangle? What is it? 3 sides. So today we learned SSS. So we're going to stop here for today. Don't lose that packet of notes. We're going to finish it for lesson 14 tomorrow.